Hello everyone, I am Soumyashree Senapati, Assistant Professor, Civil Engineering at Vedang Institute of Technology. So in this class, we will solve one numerical on while application of both normal stress and shear stress is present. We have already discussed the process, how to draw and all. So now we will solve the numerical. So what asked in question? First, the stresses on two perpendicular planes. Like you can say this AD will be one plane, AB will be plane, BC, CD, these are the planes. Okay. So, you can see this AD is perpendicular to AB, also BC is perpendicular to AB and CD will be perpendicular to BC and AD. Okay. So, now, but the stresses on two perpendicular planes through a point in a body are 50 megapascal. That says one will be your 50 megapascal and another one will be 25 megapascal. We know one is maximum and another one is minimum stress. So, both tensile with shear stress of 30 megapascal. So, this shear stress will be 30 megapascal. Right. Next word. Find the normal, tangential and resultant stress at an angle 30 CCW. CCW is what? CCW, that is counter clockwise direction. Counter clockwise direction is nothing but your anti-clockwise direction. So, we know the angle will be anti-clockwise direction, that is theta will be 30 degree. Next one, on which at an angle 30 degree CCW with the phase on which 50 megapascal acts. That on which plane the 50 megapascal stress is applied, on that plane theta will be there. Okay. In your examination questions, there will be the diagram, or else you have the question like this and you need to put these values in this drawing. Okay. Our first work is to draw the plane and apply the stresses. Okay. Like this is CCW, like counterclockwise direction. You need to first draw the angle, first draw the stresses, that is tensile, compressive and all, and also it depends upon shear stresses angles. Okay. So, we have already done the diagram here. In our next numerical, we have the question and we will draw the diagram on the base of question. Okay. So, on which 50 megapascal acts, that will be angle. Okay. We have done this. Next question is to find out the magnitude and direction of principal stress. So, how to find out, we will discuss later. Now, our work is to know what are the given data. Okay. So, first start solution and given data. Right. So, our first sigma x is given, that is 50 megapascal. Next sigma y is given, that is 25 megapascal. Next theta is given 30 degree, what, counterclockwise direction. Okay, this is your positive arch tensile stress is present. If stress is compressive, then the diagram will be little bit different. Next what? Tau is given. Tau is your shear stress, that is 30 megapascal. Okay. You can write that tau x, it is in, this will be your tau x and it will be your tau y. You can see tau x is applying in Which direction? In clockwise direction. So tau x positive and tau y is negative. So to draw the Mohr circle, we need this much data, sigma x, sigma y, theta, right? So let's draw the Mohr circle by using this data. Okay, this will be your x axis and here you have the y axis. Okay, so let's take what, 50 megapascal as 5 unit and 25 megapascal, that is what, 2.5 units. Okay, so if this is your 0, let's take it as R. Okay, here 1, 2, 3, 4 and 5. So your sigma x will be up to this point and sigma y, that is 2.5, will be 1, 2 and from here. Okay, this. So now we have the values of points of sigma x and sigma y. These dotted points are important for you. This point for sigma y and this point for sigma x. Let's write sigma x as what? 50 megapascal and sigma y as 25 megapascal. Okay. Now our work is to draw the shear stress. Tau. Tau is 30 megapascal. You can write 30 megapascal is equals to 3 unit. Okay. So we can see tau x is in positive direction. So let's draw this tau x and tau y is in negative direction. Draw it like in this way. Okay. So let's take it as point P and take this point as Q. Okay. And this point as M and here N. Okay. Now to find out the center of Mohr circle. So how to find out? Let's connect the PQ line here, right? So we have PQ line. We can see MP is similar with NQ. Okay. So this point we will take it O. Now what? We will take the OP plane as the radius and draw the circle. Here. Here you have drawn the circle. Okay. So we have find out the point O here and we will draw the angle from point O. We know this is acting counterclockwise direction, and as we have already known, in case of Mohr circle, we will use 2 theta, that will be 60 degree. So, in OP plane with this point we will draw 2 theta. So, that will be act from, okay, let us take this point as T. We have find out OT, and here it is your 2 theta, that is 60 degree, right. So, next what we will do? As always, we will draw the perpendicular from T. Okay. Let's name is as S. So, this OS is nothing but your sigma n. It will be what? Sigma n will be 20 megapascal. For perfect value, you can use pencil and eraser and all. Also, you can use it in AutoCAD. Okay. So, we have sigma n value, and in case of TS, let's take this as sigma T as what? 26 MPa. Okay. Let's draw the resultant stress. Always the resultant stress will be drawn from this point, the x and y axis point. Okay, from this point R. So now we have sigma n, sigma t and sigma r. Plus sigma t square. So we can write sigma n, that is the normal stress, 20 megapascal. It will be your RS. Okay, and sigma T. Sigma T will be TS. Let's take that as 26 megapascal. And we have already find out sigma R. That is root over of sigma n square plus sigma t square, normal stress square and tangential stress. Okay. So, you can see we have already solved the first one, the first question. Okay. So, we have find out sigma n, sigma t and sigma r. Okay. Next what? Next to find out magnitude and direction of principal stress. So, principal plane, magnitude and direction of principal plane, and also you can say principal stress. Where principal plane will be present? If shear stress is 0, then there will be principal stresses. So, first we need to find out the magnitude. To find out magnitude, our sigma major and sigma minor will be required. So, we can take from this point, the end of the Mohr circle, and up to this point. Okay. So, here it will be your sigma minor, and these to this is going to be your sigma major. Okay. We have sigma major and sigma minor. So, what will be your direction? We have the magnitude, sigma major and sigma minor. If we measure these values, we will find out. So direction will be what? Okay, you can see the minimum shear stress, that will be 0. The shear stress will be 0 at point this. Okay, this plane and here at this. Right? Here will be 0 and here will be 0. So from OP, we need to always find out the principal plane. So this angle here to here, okay, will be, let's take it as Q and what? M. So this QM angle will be going to be your what? Direction of which one? For this shear stress or tau value. Let's take that as theta 1. That will be here. This angle will be your theta 1, and for this you need to draw up to this point. Okay. After measuring it, you can find out the angle. So always there will be the question asked about find out sigma major and minor. But in case there is asking the question, in this question, if asking what? To find out direction, you just need to draw the quadrant axis and it will be easy for you. So these to these will be 90 and you can add this as 90. Only you need to measure this angle and up to this angle. Okay. So in protractor you can measure it properly and it will be your theta 2. Okay. If we have theta 1 value and theta 2 value, then we can know the direction of principal planes, and from sigma major and sigma minor we know the magnitude of the axis. So in this class we already solved and find out what? Normal stress, tangential stress and resultant stress, and sigma major, sigma minor, and the direction of principal plane. So in our next class we will solve the numerical using tensile and compressive stresses both, and we will change the shear stress angle. Let's see in that class what will be our Mohr circle. So to know that, you need to stay tuned, keep smiling, keep signing. Thank you so much.